Alright, this is the part we have to turn for this example. So basically, what we're going to do is end up facing, center drill, bring the stock out, do the turning, rough and finish, remove tailstock, part off the workpiece. And then the post we're using is going to be the Haas ST post, which I do prefer. I like to keep all Haas lathe posts turning like you would with an ST. I don't like having to flip it like the TL post does, to my knowledge. So we might to modify a little bit of the code as far as the home movements and things. We'll use retract positions and things, or reference points, if I remember correctly, to achieve what we want. But anyway, we'll process this entire part in Mastercam and be able to complete the program, including the stops to move the per part and all that. And then you could break it up if you want to post it separately. So if you wanted to just face them all and then move the stock in Mastercam, repost for the turning, and then turn them all, or whatever you want to do, it'll be broken up. So either post it all at once or post them separately. It's up to you. So first thing we need to do is go to Machine, Lathe, and I'm going to go to my Haas post. Then we need to do some moving around. So first thing I want to do is I like to keep the same top plane. I don't like to make new planes on the lathe if I can avoid it. So I'll take this entire workpiece and dynamically translate it, if I grab the front of this in the X, right up to the existing top plane and hit green check and clear colors. So now that's correct, what we're going to be looking at. And then we get into our stock settings. So I'll go to files and everything should be okay. Tool settings, I'll make sure they're sequential. The speeds and feeds are going to vary for this. When we go to make these, it's going to be multiple materials: aluminum, different types of steel, stainless, brass. So for right now, I'll tweak them for memory, but know that you have to either look them up or go from material Mastercam and make sure they're accurate in your library. It's up to you. Just make sure that you calculate that correctly. Again, there's going to be different materials. So this will be the same program, different materials, because these are tensile specimens for another class. Let's go to stock setup. Let's get our stock set up correctly. The stock is 3/8 this diameter. The length, we'll go to 5 inches just to give it some room. We can tweak that later. I'm not worried about margins for now. We'll go to preview lathe boundaries. I did think about grabbing this part here, and then bringing it out to part it off. But I figure the way I'm going to do this is I'm going to hold it over here for the second op, do all the turning, retract tailstock, and part it off. So that's the way I'm going to do this one. But there's different options there. It's up to you. So we'll leave that there, and we'll hit green check. Then we'll get into our chuck jaws. And I'm just going to go to parameters from stock, and then the grip length will be like 1 inch, and then I'll preview it, see where we're at. Not quite enough. Well, that'll work. That'll work for us. So I'll hit enter. I'm not worried about that. Again, I don't really change whether I'm using a 3-jaw or I'm using a collet. I try to stay away from the chuck. If I do have an instance where I need to get real close or things like that, then I will model it. But for most of the work I do, even if I'm using a collet block, I am staying away from the chuck, especially with like an ST machine. You don't want to be anywhere near there. So I have never really found a reason to go beyond the geometry available in these chuck settings myself. Okay, so we'll hit green check, and then I will define a tailstock now, and this needs to be accurate to the machine, but from right now I'm going to position it 10 inches away, preview it, make sure it's out in space, that's good, and then hit green check. Now make sure this is accurate to the center you're actually using on your machine. So then I'll hit green check. And this is going to be our setup. We're not going to have the tailstock all the way at the end. It's going to be retracting. We on the ST at the college, we don't have a tailstock because it's a smaller ST. It's an ST15 and it has live tooling, so there's not a lot of room for a tailstock, unfortunately. So this will be done on one of the TL lathes. So it's manual tailstock. So we're going to get codes for the tailstock, M21, M22, if my memory serves me correctly. And what we'll do is end up either deleting the tailstock codes and leaving the MO1, MOOs from the post, or updating those in the program, depending on how we're going to go. Now this is going to be the main setup. Okay, the problem is with this setup is that this is 3/8 diameter. It's the stock. It's a little bit hanging out a little bit too far, in my opinion. And for the sake of this video, I know some people will say, well, we could hang on to here and face it, turn it, cut them to length first. That's fine, but I wanted to show some techniques in this video with a part that actually is going to be assigned to be actually made. So let's update our stock setup in our chuck jaws, and get the parameters. And let's change the grip length to 4 inches, something like that. Preview. So even that's pushing it, but we'll leave it there for now. This will be perfect for our facing and center drilling operation. Okay. So we'll hit green check. There we are. All right. And then I'm going to name the first toolpath group. This is going to be just operation. The operation 1. Or just op 1. All right. In this op, we're going to do the first thing we're going to do is a facing operation. So we're turning, face. Okay. I'm just going to use a, well, on a TL, since it's a manual tool changer, we're going to have 3 tools for this. It's going to be our CNMG, our 80-degree rhombus, center drill, and then, well, 4. Then our VNMG insert that's center cutting, and then the parting tool. So we'll go into our library. I'm just going to use a regular 80-degree rhombus here. Green check. There we are. For feeds and speeds, again, this could be for different materials. For right now, I'm going to put a max spindle speed of, let's say, 1500. Spindle speed, a constant surface speed of 200. And a feed rate of 10,000, let's say. Okay. We're okay with this one. The reference point I am going to put in, and this is on radius. So, you know, so if you put 3 inches, here it's 6 inches in the code. So I'm just going to go, let's say 1 inch on the X, or yeah, 1.5 inches on the X. And then Z0. And this is going to be absolute from the gnomon. So that's where the machine's going to start and stop in a way. That's not a bad way to go, especially with the tailstock here. We don't want to send it home every time. So we'll hit green check. Next thing we got to do, everything else here should be okay. We'll hit green check. And there is our facing operation. All right, if we go into backplot and hit play, that's it. Okay, actually I'm just going to go through this quickly here. I just use the S and B buttons on the controller, so that's it. Alright, so the facing's done. Let's take care of our center drill operation. So we'll go to drill toolpath, select library tool. I'm going to pick, these are all spot drills. There's a center drill, 1/4 inch diameter would be fine for us. Go ahead and check. And then as far as the depth, you can calculate that out. It's up to you. The depth I'm going to go is, let's say, minus 0.125. Absolute. Everything else should be okay. Alright, yep. And the speeds and feeds, if we're going to feed rate of inches per rev, let's go 10,000 IPR. And you can go to a constant RPM. Max, it doesn't really matter for this one because it is RPM. And that's fine for now. Again, these need to be tweaked for the material. How you get that is up to you. And this would be center drill. Turn the reference points on. I think we did 1.5 from before. And Z0 we need to update for this one because it is Z cutting, so we'll go 1 inch. Green check. That should be okay. If we go transparent, you'll see that is not quite getting as deep as we should, and this center drill is a little bit large for this part. Now that may not be in the world, it really doesn't make a difference for this workpiece as long as it supports the work. Let's see if there's any other options. 1/2 inch center drill, 1/4 inch. I'm not seeing anything. There are some spot drills. We'll live with this one for now, and we're going to tweak the depth a little bit. Let's go minus, double that. Let's go, actually, let's go 3/8. Alright, and that's too far. Alright, what I'm looking at, if I go like this, so I'm looking for the taper to be in the right position. Okay, so let's go, and we can calculate it, you know what I mean, if you went here, you know, whatever that would be, you could tweak that however you want. So let's just go 1/4 inch. That works. Actually, it's still a little bit too much. So let's reduce that to 220. That's fine. So that'll work for us. Okay, then we'll have to make sure our center matches that, and that's close enough. I don't go with this. This does matter, so don't confuse. I want to make sure I don't confuse anybody. The center coming in, unless you're really getting close to it, is not that critical. Okay, so there's a spot drill. These do operations. We can watch them run. Okay, And that should be okay. Again, the 10-inch away from there should be plenty of room to work. And then what I'm going to do before I transition here is do a new toolpath group, and I'm going to call this toolpath group move stock tailstock and tailstock / tailstock, something like that. Alright, I'm going to save now, and this will just be I don't know, tailstock part example. This will just be on the desktop. Alright, so I'll transition here, and then we'll start moving the stock around, bring the tailstock in, and getting ready for Op 2. Okay, so now what we need to do is simulate moving the stock out in preparation to machine this area here. And in Mastercam, what we're going to do is actually move the chuck back. We're going to keep the same gnomon. I definitely recommend on the lathe, I don't do additional planes like I do on the milling machines. You watch my other videos, I move planes all the time. I usually don't even use existing top plane on some Mastercam programs on the milling machine. On the lathe, I stick with the same one here. It usually works out better for me, especially during posting. It may not affect Mastercam, the interface, much, but it definitely, I've had post issues with that, and maybe it's me, but just be aware that I keep that same plane for all my ops on the lathe work. So in the part handling gallery, we're going to go to stock advance, and we are not actually going to be moving the geometry. Okay, what we're going to be moving is the chuck. So the chuck original position is where we are now. We're going to go minus 4.0 and hit green check, then hit green check again, and you'll see the stock move. So this is where it's going to be for this second operation. If you want to go back to the first op, I just move my red cursor here. There's our first op. Move the red cursor, second op. Okay, so that's how to move it around. Now, let's bring the tailstock in. Good time to save. Tailstock is right here. Okay, so the original position is 10 inches away. The transfer position, if we leave it on auto, let's see if that calculates correctly. Okay, let's see if it meets up. If we hit green check, it does perfectly. Okay, so that is based and it's reading your center drill position. So this is perfect. Okay, advance or retract has to do with, you know, if you got a hydraulic tailstock like on other ST or turning centers. We don't. We're gonna end up deleting some code for this one. There's nothing in here to really mess with that I'm aware of, so we'll just delete it in the post. We'll hit green check, and that is accurate. So now we're ready to turn this center portion. Okay, I'm gonna do a new toolpath group just to stay organized, and this will be Op 2. Okay. All right. So now that we have Op 2 created and we're set up, let's get ready to rough this out. So go to the roughing operation here, and I'm just going to select this geometry that we need to move. And you got to be careful selecting like I just did, because sometimes it'll break it up into 3 planes. So I am going to delete that, and I'm going to select here to here. That way it guarantees you one chain. We'll hit green check. And then we need to find a tool that will machine this that I'm trying to remember if we have, you know, at the college. So I'm going to go to select library. There's nothing in here that's really going to work for us. One of these OD finish tools might make it, but I'm not going to push that. We're going to use one of the center. There should be a VNMG insert, the 35-degree center orientation of the insert. So if we go to Kennametal, and then right here somewhere is some VNMG inserts somewhere. Let's see here. So make sure I got the ones that are available. Now, again, these would work as far as code for the most part to see if we're going to crash, but it is good to see and make sure that we have the right tools. So there's one right there. So 30 thou straight holder with a VNMG 332 insert. So 30 thou. Yeah, either one of these will be okay for us. Make sure you match it to what's at the college. I am working from memory right now, but this will be close enough for our example. And that should come in as tool 3. That's fine because the center drill is the other one. For speeds and feeds, the max spindle speed, I am going to kick that to 1500. The surface foot is 200. Plunge feed rate's fine. Feed per rev, 10 thousandths. Okay. This will be roughing. Make sure the reference point is on. and it's going to be 1.5. That's good for us. And Z0 is not great. It's going to be like right here. I mean, it's not the end of the world. We should be coming from there anyway, so we'll leave it because that's where we're leaving on other operations. So we'll hit green check and go from there. The only thing is the other op is going to be an inch away. We just got to make sure. What I'm really worried about is the saddle of the lathe hitting the tailstock base. So just got to watch for that. So we'll leave this for now. Go to rough parameters. Everything should be okay except for we need to do a couple things here. We need to use stock for outer boundary. And I'm going to go to adjust stock and make sure that our stock area to machine is correct. In, lead out. What I do for this operation is I'm going to do automatically calculate entry and exit vectors. They're separate. Plunge parameters need to be allowed to dip in. I don't know if that's absolutely necessary, but we're gonna do that. It might just read it as it is. And we're gonna do automatic depth of cut of like 20 thousandths with a minimum depth of cut of 5 thousandths. Just take our time, working our way in. Leaving 10 thou and X and Z is fine. Let's hit green check and see what it comes up with. We have an issue. Can't compute entry vector. Why is that? So let's look. First thing, when the tool goes across a workpiece, look at your geometry. The arrows are the wrong side. Right click, change side, green check, regenerate. Now it's correct. Okay, so let's run this and let's make sure we don't have any issues. So we'll hit play. Looks okay. Now don't worry about the blue lines going over. Okay, let's actually look at this. Let's slow it down. I'm gonna go back a couple times. See how it is staying away. That's the tool nose compensation on. Okay. So the in is okay, or the lead in. Let's go out here. That looks okay. That looks okay. And that looks okay. Alright, if we actually run this operation, just this one, notice that the chuck and the tailstock go with it. This is our start location, the reference point. We slow it down and hit play. It looks okay. Alright. So that's good. Time to save. And I'm going to turn that the toolpath lines off. And what I want to do now is let's do a finish operation. So go to finish. And I'm going to select this geometry. And notice it did not link up. So I'll escape and I'll actually use the forward button, and that's one other way to do it. So these buttons here, start end operations, or start end of the chaining options. Green check. Same tool. Feed rate will slow down. And the surface footage we could kick up, but that's up to you. This is finish. Reference points. And I think it was 1.5 and 1.5. Something like that. Finish parameters, lead in and lead out. One thing I'll do here is put them both to tangent and hit green check. Again, the plunge parameters, I don't think it really matters, but we'll do that. And that should be it. We shouldn't have to extend contour to stock. I think we're okay, but I'll leave that there for now. That was sort of like stock recognition and finish pass. So we'll hit green check. And what happened? The tool path is out of whack again. So how to fix that? Geometry, right click, not change, or yeah, change side. I'm sorry, don't reverse it. Green check. Regen the op, and it looks okay. Now tool nose compensation is on, so be aware of that. Let's take a look at this and verify and make sure we're not overcutting or undercutting or anything weird like that. So there's our roughing, and there's our finish, and it looks pretty good. Okay, right to the green lines. I don't see any issues. So again, don't get confused by the blue lines. Okay, that is automatically taking care of tool nose radius compensation. So if you ever program manually, you'll know that you have to do that. So notice where it's cutting. Okay, this is the roughing. Actually, I didn't want to focus on the roughing. It's not going to help us in what I'm trying to show you. So we'll go here and watch the tool path. So notice the tool is cutting correctly. So if we slow this down and hit play, see how the tool is correctly? That's because the tool nose compensation is doing its job. It only matters when you're cutting in the X and Z at the same time like we are now. So there's tool nose comp. If I stop and go back and then slow it down and hit play again, you'll see it's going to go the other way to compensate to the part from the tool nose radius. Okay, and hopefully it leads out a little bit. So that completed the part right there, and it leads out a little bit, so that's good. So that is done. All right, so op 2 is complete. All right, good time to save, and I'll put a transition here, and we will finish up with we'll do another tailstock move, and then we'll part it off. All right, so let's do a new toolpath group. So we'll go groups, new toolpath group, and this will be move tailstock. And then in this operation, we will go to tailstock. And then it's the opposite, retract. It kind of automatically does it, so we'll hit green check. And it kicks it out of the way 10 inches. Okay, you can tweak that. As long as it's out of the way, it doesn't matter. Because again, you're moving this manually. It's not like on a turning center where this is hydraulically or controlled with a servo motor or something. Not CNC controlled. You're moving it manually, so it'll be an MOO to do that. So now we can get into our last operation, new toolpath group. This will be part off, or cut off, whatever. And then for this operation, we'll get into here. We'll go to cutoff operation, select the end of the workpiece. And then in library tools, instead of the Kennemental library, I'm going to go back to the default Mastercam lathe inch library. And I'm going to select this 1/8 inch cutoff tool here. That's good. Make sure that you do your reference points. 1.5 is fine. Z0. And this will be part off. Something like that. Speeds and feeds, max spindle speed I will put at, let's say 500 because you don't want this thing going flying. Spindle speed 200 and a feed rate of 1.5 is fine. Now the cutoff parameters from stock for your entry mount is good. Everything else is going to be fine by default, but let's say I want to automatically deburr this backside. You know what I mean? We can do the same thing in the front with a chamfer. We didn't. We can go back and do that, but this is one thing I wanted to point out. If you want to chamfer during the cut, you go to parameters. The width of the chamfer be 15 thousandths. Okay, 45 degrees, that's fine. Hit green check. And then if you wanted to peck, those pecking values are here, but this part doesn't warrant that. Lead in and lead out is here, but this is the corner geometry. So if we hit green check, you're going to notice it's going to cut a little lead in here for the workpiece. And you'll see it'll cut a little 15 thou chamfer there, so you don't have to deburr it. Okay, just something different. It goes down past 0, part would part off. Okay. Alright, so let's go back and add that little deburring cut in the facing operation. So we'll go up to the lathe face, go to corner, and add a width of 15 thousandths chamfer, and we'll hit green check, and you'll notice that now there's a little chamfer there. So that's just a way to quick have the machine deburr the workpiece. So we got to regen everything now. Let it process. And now we're ready to actually watch this run. We actually look at the facing op now just to make sure we look okay before we go into verify. So we hit play. Now notice how it came in. So if we just watch that op, it comes in with it because we're not cutting the OD. See, so it's just like the parting tool. It's just on the other side of the workpiece. So 15 thou is fine, and you can tweak that any way you want. It could be less. It doesn't need to be that much. So that's it. So let's take a look at this in code. So you're not going to really be able to run this whole thing in one shot. You're really in the way we have it set up in the TL. So what I recommend is you're going to end up running op 1 first. Op 1 is going to be facing and center drilling, because we're going to shift the workpiece out now. All right, and so if we look at this in code, This will be op 1, and this you'll run all the parts in op 1. All right, I would run almost all of them. That where you know, depending on if you go from stainless to aluminum, you can't do that. But I would run them all. I'd even run aluminum slower. I'd run at stainless speeds and feeds and just run them all. It'd just be faster. You're not making that many. But anyway, so there's our reference point, Z0, X 3.0. Face the workpiece, our little lead in. Go back to X 3.0, Z0. We have to get rid of these G53s. Can't go home because the tailstock's going to be in the way. MO1 is fine. Run the workpiece. Get rid of the G53s. This is op 1 program. Okay? You can't run it all in one shot because we are actually moving the workpiece out and changing our Z G54. Okay? So this is good for op 1. To do op 2, we would select the rest of the operation. So minimize op 1. And you could have changed the tree instead of linking the tree right here. These could have all been together in trees this way. But I think it's easier just to hold control and pick what you want with something this short. So this is the rest of the operations because the G54 for this op ends up looking like that. All right, so these two ops are the same 0, 0. So this would be after they're all faced and centered. Okay. Now we can run this. Okay, because then op 1 is not selected. We'll post it. We're not going to post everything. And this would be op 2 as you load it. Okay, and then you would run all these at the same time. Again, it just speeds and feeds for materials and things change. It depends on how many you're making. So again, it's starting with an MOO. We don't need any of that. Okay, this is sort of mid-program. It's up to you about moving it. You don't really need that the way we're running it. So we're just going to hit delete. And we'll hit delete. Well, it's up to you. What I would do is I would go MOO. Just to make sure the tailstock's engaged. Okay. And then notice calls up T3, the right planes, coolant's on, spindle's on. It goes to Z0 and Z3.0, so that should not mess with your tailstock. Tailstock should already be positioned so that these numbers would work. All right. Everything else is good here. It starts roughing. It goes back to its reference point. It finishes. Goes back to the reference point. Get rid of these G53s. Now, I'd leave these M1s, M00, and even take the M22 put to M00 to make sure that you do retract the tailstock. That's critical. Otherwise, you're going to have problems when you part this off. Then it goes into tool 4. All right. It goes to the reference point. All right. It should already be at the reference point, but make sure we're there again in case something changes. Okay. You are doing a tool change, so you should have plenty of room for at X 3.0 on a 3/8 workpiece at Z0. That's the center of that's the edge of the cutting tool. You should have plenty of room. Go ahead and part this off. All right, there goes past that X minus there, back a little bit, retracts, reference point, ready for the next part, and then get rid of the G53s. And unless I'm missing something, that looks about right. So this is a 2-op workpiece technically. So that's really it. I don't really think there's a point in doing a view sheet for this. That's really it for this one. I think I covered everything I needed to do to make these. So if you have any questions or comments, let me know. If I missed something, let me know. But everything looked good to me. So if you have, again, any questions or concerns, email me or leave a comment below. And thanks for watching.